Okie dokie. Can everybody see that okay? Did I pick a right platform theme? Is that okay? Visible? I don't know if there's glare.
No.
It's okay? Okay. I usually have everything in black and white. That's why I ask, because of the other. I have a monitor that I do some of my talks with. It's half broken and only shows me like one color. So I haven't played with themes on PowerPoint in a really long time. Yeah, everybody, you've all got little pieces of tissue paper there. It looks like we'll probably double up in order for this to work right. So I'll think about how we'll do that because it's important. There's 5 conversations that we have in our healthcare system that are really kind of a values-based conversation. And it's something that when I have patients in my office, I introduce the topics. Last month we talked about vitalism versus mechanism, being the concept that the human body, if you come from a vitalistic point of view, is this self-healing, self-regulating organism that knows how to adapt to its environment. It learns from its environment and then creates an adaptation to grow, not only to just survive, but to grow and thrive in that. The other concept going on in healthcare right now is mechanism, meaning that if you have A disease, you add B intervention to get C result. And the whole reason that we have side effects from medications is because the body doesn't work that way. It doesn't work in a linear model. You can't just take out a part and expect the entire organism to work better. So depending on where you fall in your ideas of how the body functions, helps you make your healthcare determinations if you find providers that are aligned the same way. The next concept that we're going to be talking about tonight is naturalism versus artificialism. And to define the two, naturalism being the natural process that happens in your body. We all know that we're born, we go to be little people, we get to be slightly bigger little people, we go to be adults, and then we die. There's this natural process that happens. There isn't anything in the history of mankind that stops that process from happening, right? You're born, you die. You don't get to do some other option. So that's kind of the understanding the natural process, meaning which is the best way for the body to develop, which is the best way for the body to be born, which is the best way for the immune system to develop, what's the best way to have your gut develop, what's the best way for your body to function. That's really where this question's going. The second question up there is do we have some medical advancement and overreach going on in our society? Yes, absolutely. In the 1960s, we were coming up with really, really brilliant ideas. We've doubled our life expectancy because of some of the medical technology that's been out there. But some people will argue that some of that science and some of that overreach has really started to impede the health process. You only have to look as far as the hospitals in MRSA to understand how that's happened. That when we, in the 1980s and 1990s, when we started making antibacterial everything, we used to put bleach in everything, and the idea of a clean, sterile environment was a good thing, ended up in something called MRSA, which is essentially a penicillin-resistant form of staph. And it was a big problem in the hospitals because they couldn't give someone an antibiotic if they had an infection with MRSA because the antibiotics ceased to work. It became a bigger problem when people started coming in from the community into the hospitals, because at that point it meant that MRSA had broken out of the hospitals and is now in our community. We still don't have a really good solution for that. So if you get a MRSA infection, when we start talking superbugs, it's kind of because we caused our own problem there. So we're starting to question maybe the basis and the foundation for how we're choosing our healthcare options. And this gets really important when you're making decisions not only for yourself, but for your kids and for your parents too. Because a lot of times when we're talking about these shifting generational values, the way that people fall on these spectrums really kind of goes to where they grew up. My dad grew up in a if it ain't broke, don't fix it kind of mentality, and if you can fix it with duct tape, you're good. If it's not sticking out of your body, then you can walk it off. At the same time, we have a conflicting idea of an ounce of prevention is worth a pound of cure. When we start talking about naturalism, we start talking about is the best way to make an immune system work better through natural exposure of things like dust, dirt, dander, mild forms of microorganisms. And we're going to talk about that tonight, about why that might be and some of the science behind having the body work better. And I think part of the reason that we ended up getting so skewed is because we stopped studying the immune system. And there's some really, really important advances just in the last 5 years. I mean, really what's happened is our chemistry and our microscopes have gotten better. We started discovering some things about the immune system, and it's really recent. So I don't blame a lot of doctors for not knowing this stuff. It's fairly recent advances. I mean, who heard of probiotics 5 years ago, right? I mean, those kinds of things are just starting to now be discovered, and so we're going to talk about that tonight. In order to get a good framework for how this is going to go, whether the natural process, it's kind of important to go back to the beginning of you. So when you were 2 half cells getting together to make 1 cell, and you made 2 and 4 and 8, and you kept growing and dividing into this big ball of cells, something really cool happened. This groove started to form, and all these cells started to tumble into the groove to make a tube. And that tube was the very, very first structure in your body. It was going to be your brain and your spinal cord. And then everything started branching off of that just like buds off of a tree. So that by 3.5 weeks, you had the eye start to form. You had things like your heart pumping little blood cells by 4 weeks. You had little buds that were going to make your hands and your arms. And this process keeps growing until by the end of 12 weeks, you weigh about 2 ounces and you're about the size of the end of your little finger here. I mean, that's pretty cool. You just keep this growth and development. As you keep on continuing to grow, I mean, even your lungs are fully formed at that point in time, ready to go. So you could take your first breath, even though you're breathing amniotic fluid, right? You've got no real thing to breathe at this point. When you come out that birth canal in 2 more trimesters, that's the very first kickstart for the decision process of your immune system. There are really 2 ways for you to come out. You can either come out naturally through the vagina, or you can be born by cesarean section. And depending on how you're born, that's really going to make a difference on how your immune system is going to start kickstarted. When you go through the birth canal, right now, when you're inside mom, you have an immune system that's shared with her. I mean, it's all her. You're connected by that umbilical cord, so you're sharing blood in through the placenta, and you've got an immune system that's really full of mom's antibodies. Now, mom's antibodies aren't attacking your cells because her body's immune system has actually made a big shift while she became pregnant. You have 2 different kinds of cells that run in your body. Ones that are kind of a permanent one that's there all the time, and you have another kind that's called antibodies. That's what we hear about a lot. And antibodies are also responsible for things like allergies. Our body will actually make a shift into more of an allergic response when we're pregnant. And that helps a lot of people explain like why we start getting more sinusy when we're pregnant, or we start getting more acid reflux when we're pregnant, or we start getting like weird itchy things, allergic to things we were never allergic to before. The reason for that is because it's called a Th2 shift, where your body is shifted into more of an allergic response. And we're going to talk about that so we can understand that a little bit better, because it's really important to understanding how to grow your immune system properly. But when you start off as a baby, because you're sharing that blood, you've got that Th2 response too. It's a great big allergy response, ready to react to funny looking proteins. When you're born and you get passed through that canal, what happens is you take all of mom's natural flora that's lining the birth canal, and you get kind of your first meal. It's shoved up into your nose, into your mouth, and that starts to line your gut. After that process, 80% of your immune system actually comes from your gut. 80%. That's a huge amount, right? And so we've got all these immune cells that are lined on the outside, these lymph nodes that line the entire digestive tract, and based off of the bacteria that are actually inside your body, your immune system starts to grow and develop. If you're born cesarean section like I was, you don't get that shot. So, there's some obstetricians who are aware of this, and they're starting to do things like swabbing the canal. They'll put some of that on the mom, so when the baby gets to nurse, we at least get some form of the microflora getting into the baby's system. If not, you have another good opportunity, and that's when you start breastfeeding. That very first release is called colostrum, and that is full of great immune system boosting chemicals. After that, you still share mom's cord immunity for 3 to 6 months, some of those cells will last inside you. So you aren't left when you're born totally unprotected against the world, just this baby in the woods ready to die from any little bug that's coming your way. That is a great big fallacy that we've created in our society, is that babies are completely unprotected when they're born, because that's not really true. I mean, it's partially true, and I'm going to talk about why we've kind of developed immune systems that are a little weaker, but as a whole, our immune systems are ready to go as long as your immune system has been prepared and ready to go. Hi. You can purchase bread, you can stay for a talk, you can do anything. I was talking about how the immune system starts off a little bit shifted in one direction, and then the goal is to shift it into the long-term permanent immunity. When your immune system when you're born, it's pretty much a clean slate, ready to start learning about things. It's called undifferentiated. When I was talking about that ball of cells, that's an undifferentiated ball of cells. When it starts to make differentiation, all that really means is that a cell has decided to become a liver cell, or a cell has decided to become a heart cell, or a blood cell, or a white blood cell. That's what that word means. When you're nursing, one of the most fascinating things I ever think about breastfeeding is that not only are you providing, like we've all known I guess the science has been out for about 20 years. It says that a mom's milk will change based off of a baby's needs. And I always thought that was really cool, but I didn't really get it. I didn't understand, how does mom know? That's pretty neat. What happens is actually you have two-way ducts. And there's ducts that come out and give milk, but there's also ducts that come in. And the baby produces these chemical messengers inside their saliva, and those chemical messengers actually come to ducts that go inside your body. When they go inside your body, it tells your body what to prepare. It's like a grocery list for your baby. I think that's really sweet. That's pretty cool. So if you've got this immune system that isn't shifted properly, if you're born by C-section, it's still okay. Like I said, the colostrum will go ahead and give a boost to the immune system. You can go pull that up. We're going to use it in a little bit. The colostrum gives a great big boost of immune system chemical, but then your body keeps on producing not only the probiotics, the good bacteria, but also the prebiotics, which is the sugars that those bacteria are going to need. It produces that as well in order for your body to take that information and grow. So obviously, when we're talking about naturalism versus artificialism, what's the best way for an immune system to develop? Be breastfed. It doesn't matter how cool the science is behind formula feeding, formula still can't read what your baby's doing on the inside. And that's why we see more colics, why we see more spit-ups, that's why we see more digestive difficulties, because formula is made kind of as a broad solution for babies instead of a specific solution like breast milk is. Is it okay if we have some moms that can't nurse? Yeah, absolutely. I mean, it's a great substitute. But if you have the option, it is absolutely important in order for your baby's immune system to function properly to go ahead and breastfeed. In fact, it works so well that we're going to talk about vaccination in a little bit, but it works so well that when we try to shift the immune system with vaccines, actually breastfeeding causes vaccines to fail. And I'll explain what that means. So there's some recommendations out there to not breastfeed when you're giving your baby shots because it interferes with the vaccine process. I'll explain why that is. I mentioned a little bit about how our bodies should take on mom's immune systems, right? But there was a really interesting study done just a couple of years ago about that. When we start talking about the impacts of vaccinations, a lot of times we get kind of myopic. We look at what's happening right now. And we haven't done a whole lot of multi-generational studies on this. They're starting to now. And there was a study done by in the British Medical Journal where they looked at measles, women who had measles as children, and women who had been vaccinated against the measles virus. And then they looked at their children, and they looked for antibodies, maternal antibodies to measles. And something really interesting happened. In women who actually had the measles, their babies actually had 3 times the amount of antibodies to the measles virus their children did when they were born. And those immune system cells, like I said, they start to die off after a while. Well, they actually lasted 4 times longer than the women who were vaccinated as children against the measles virus. So not only did they have more immune system cells and they lasted longer, but 26% of the women who had actually gotten the measles shot, their children didn't have any protection whatsoever. So here you are, you've gotten the measles virus as a child, you go to make a decision to have a child. Now your child already has automatic protection against the measles virus. That's pretty neat, right? If you go ahead and get the shot, like most of the kids are here in the United States, a quarter of them are going to give birth to children that have absolutely no protection whatsoever. So what do you think the recommendations were on the study? We should give the measles shot earlier. Right? Makes you scratch your head, you know? It's like, well, what about getting measles and then having the longer term natural immunity, right? So this is kind of where we're going to get a little bit of more of a hands-on demonstration on how the immune system grows and develops. We're going to end up doubling up a couple of these, but I need a couple volunteers. Who wants to volunteer? Okay. I need one more volunteer for that seat right. Stephanie, you're a volunteer.
I was just going to say, I'll do it.
Would you mind, Katie, volunteering for red?
Sure.
Okay.
You should pay attention to 2 things now.
I might just have people drop one. Yeah. So the way that the immune system works, I'm going to kind of color code things for us so it's easier to understand, because it can get a little sciencey, it can get a little heady. So this helps to kind of break it up a little bit. When your immune system, whenever you get, let's say some microorganism has come into your environment, right? And the first thing that it does, let's pretend like we're all babies, okay? What's the first thing that a baby does with something when he sees it? Puts it in the mouth, right? There are 6 million taste buds in an infant lasting up till they're 6 years old. They start to die off. That's a huge number for those of you who are trying to count the number of taste buds. Huge number. And they have, the reason for that is because we use this just as much as we use our eyes when we're infants. It is all about reading the environment, all about developing that sensory experience. So we're going to pretend that we're going to take something we found and we're going to put it in our mouth. You've got a layer of these cells. They're called dendritic cells in the mucosal layer of your body. That's the green ones. When it comes up to something, it says, okay, green alert. We got something going on. So it tells this organ right here. It's called your thymus. It tells the organ in the thymus about whether or not the body's got this, whether or not it can take care of it on its own. Because the thymus is where we start making 2 different kinds of cells. We actually have a lot of cells in there, but there's 2 major types. The first one is called Th1, and I'm going to refer to that as a chickenpox type. Those of you, anybody here have chickenpox as kids? All right, so once you have chickenpox, you always have chickenpox, right? You've got that immunity for the rest of your life. Okay, so that's Th1. You have Th1 immunity to chickenpox. The other kind, the Th2 kind, is the antibody kind that I was talking about earlier. So if you get a shot for something, you have a Th2 response to something, okay? Those are antibodies. It's an emergency response. So this is how it happens. Microorganism comes into your body. First level of dendritic cells says, hey, threat level green, we're okay. You guys sitting down there at thymus school can just kind of chill out for a while. We don't have any major need for you, okay? So the body goes back to doing what it's doing. Now, usually the body takes care of this, a nice green snot, and you blow it out, and no problems, right? Let's say, though, we've got an immune system that's gotten compromised, and we've gotten to the second layer, okay? We've got threat level yellow. So threat level yellow comes up. It's the second level of dendritic cells. And those guys are actually on the inside behind those front line of defenses. And it says, hey, thymus, just want to get your attention here, okay? We've got a small problem. We've got microorganisms that are no longer on the outside of our body. They've come in. We've still got this, though. We've got a lot of layers of defense here. I mean, your immune system has like 8 arms, and so 6 of them at this point in time are working. They're sitting there trying to beat back whatever's there. I mean, these great big, marine kind of cells, the ones that your mom gave you through the cord blood are there. They're circulating around and attacking things. So they're there. It says, just want to get you aware that we might have a problem, but so far so good. So the thymus at this point in time is still got a bunch of undifferentiated T cells, okay? Not Th1, not Th2 yet, but they're starting to make a decision, right? So then we have threat level red. This is where we've got a problem. When we've got a problem is when that microorganism has no longer is floating around inside the body, it's actually gotten into a cell. When we get threat level red, then a whole cascade of events happens and tells thymus cells to come and get active. So that's where I'm going to take you to. Come on up.
with this or without
Yep.
this?
Oh no, you're going to bring your orange.
Oh,
yeah,
okay.
yeah. Go ahead. Both of you, come on up. Honey. Come on up. I'll be this one. Okay, so here's our cell. Here's our invader, and it's waving a sign. It's waving that sign. It's saying, "Hey, look, I've been invaded. I've been invaded. Help me out." Okay. When that happens, Th1, this one, brings along a buddy. Th1 cells are circulating around your body. They get released out of your thymus, and they look around for funny-looking cells. They're really good at telling who's you and who's not you. That is their job, to tell self from non-self. That's essentially what they do. When you start waving around the I've been attacked billboard, Th1 cells look at it and go, uh-oh, we need to do something. So they call Guido here, their natural killer cell. They come in and take care of you, see? And so Guido comes in, the natural killer cell comes in, shoots a big bullet into this cell here, and it explodes. We have cell lysis. All the stuff on the inside of the cell goes out, and then the body does something really important. Instead of keeping it inside your body, it pushes all the stuff out. So it comes out in snot, it comes out in vomiting. Away we go. Yeah, away we go, away we go, away we go. It pushes it out in snot and rashes and diarrhea and all kinds of symptom stuff, right? That's a Th1 reaction. It's a reaction of expulsion. Okay. Th1, we've done our job. Great. Now,
But I thought I killed it.
you did.
But you said Th1.
Th1 did its job. Yeah, it called you in.
Oh, okay.
Yeah, it called you in. You're the one, right?
Got it.
Yeah, okay. Please, have a seat. So now, if we've had an emergency instead of going through our 3 levels, right? Green, yellow, red. If we go straight from nothing to red, then there's something else that happens. That's you guys. Come on up.
Then 2 or all 3.
All 3 of you. So, come on over, microorganism.
I'm going to attack you again.
Okay, so we've got a cell, and it's sitting there, and all of a sudden,
I know what I have to
this
do.
one comes in, and gets me.
Oh, just
Yeah, it gets me, right? All right, so it gets, no, it's okay. I knew what you were thinking. That's what's going to happen next. What happens then is antibodies are produced. And antibodies are these blue ones right here, okay? The antibodies come in, and they say, uh-oh, we've got a problem. We need to surround this one. So go ahead, you can surround it. This one here, the light blue one, that's antibody's really, really good friend. Anybody's really, really good friend are called IgE. And IgE, for those of you who have any kind of like allergy or friends with allergies, should sound a little bit familiar. Because when they're doing allergy tests, they're looking for either IgE or IgA. Now IgE is a really, 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 really powerful immune system cell. What it does is it helps look for parasites, okay? That has been a very, very long historical use for IgE, but guess what? We don't have parasites in our systems much anymore, so it gets bored. It looks for any kind of weird-looking proteins, and so that's, I think, why part of the reason is that we get IgE reactions to things that we're putting in our body. We'll talk about that in a second. So IgE is coming in too. You guys are going to get it too, right? And then something else happens. This is called complement. And complement is also a super powerful chemical. It's a bunch of stuff that comes in to the cell and it dissolves it. So we've got surrounding and dissolving, right? Right? So come on in. Surround, dissolve. Surround, dissolve. Very good. Thank you. All right. Thank you very much. Hope you enjoyed that, folks at home.
You need to go do that at school.
I know, right? Where do you think I got the idea?
Unless you want to hold on to it. No.
So, we've got 2 different things happening, right? We have chickenpox type, so that's Th1 immunity. And Th1 immunity is a long-term cell immunity that you build. That's the one that comes in, and once it identifies that that microorganism, that the billboard that's going up there, it remembers it for a really long time. like I said, its job is to tell what's you from what's not you. Can you see how that would be a problem when you're pregnant? That if you had a really strong Th1 response when you're pregnant, we'd never get pregnant, right? Yeah, if we had a lot of autoimmunity stuff going on, it's because we've got a problem with our self versus non-self recognition. Does that make sense? Yeah? Things like cancer, things like autoimmune diseases like lupus, rheumatoid arthritis. Usually those people have a really strong dominant Th1 system, okay? Just like anything in life, there's a balance here, right? We want kind of strong Th1 because we want the long-term immunity, but it can get out of balance a little bit, okay? It is the immunity of expulsion. Its job is to get stuff out of your body. I have a lot of parents who come to me and they say, my child has a fever, my child has a rash, my child has vomiting, my child has snot, whatever, right? I go, yay, every single time. The reason for that is because that's an immune system that's doing its job. It is absolutely functioning properly, and we want to do everything we can to A, keep the child comfortable, but B, encourage that thing to get out, right? So if you have a fever, you aren't suppressing it, you're encouraging the body to spread it, evenly throughout the body in order to break. We aren't giving Tylenol to dampen it, we're trying to encourage the proper development of the immune system, right? It's a slower immunity though. You saw all the levels that we went through, right? The 3 levels of dendritic cells. It takes about 7 days in order to get a Th1 response. That's how nature has designed it, because we have lots of other ways to take care of things before we need to start activating our thymus, okay? We have all kinds of mucosal layers. We have good beneficial bacteria that are in there that help keep things in balance. We've got, if you want to open up an immunology text, you'll see we've got a ton of stuff before we get to the antibody versus Th1, cell-mediated versus humoral response. Once we get to that chapter in the book, we've already covered a lot of stuff, all right? So there's a lot of things, a lot of ways that your body will take care of things first. Now, it does give you, if you're going to look at one of those immune system charts for how immune you are to something, it does give you about 60% immunity. If you're going to look on there, it's about 60%. So if you get chickenpox once, can you get it again? Yeah, you might. But the chances are lower, okay? Because those cells last for a really, really, really long time. We've got a really long memory when it starts to come to Th1 cells. Those cells are lasting like 30 years, 60 years. The idea is, let's say you get chickenpox as a kid, and your kids get chickenpox. You're in your 20s. Guess what? You've got immunity to that and a bonus exposure. So then, guess what? You get to carry that immunity on without having to go through chickenpox again. And then you have grandkids, and guess what? They get chickenpox, and you still got the immunity. That's kind of how that starts to go. I think part of the reason that we end up with things like shingles is because we stop getting exposed. That virus comes back into our systems, and it's kind of a new thing for us. It stays along some nerve path and then breaks out in a really painful response. Remember that complement thing I mentioned? Complement. Things like histamine. Heard that with allergies, right? Histamine is part of complement. There's a substance called substance P. P stands for pain. That stuff hurts. When you sprain your ankle and it swells up, you've got all kinds of substance P in there. That's the pain and swelling chemical. When you get something like a shingle and it hurts and it breaks through and that's nasty, it's because there's lots of complement in there. Yep.
What about if you get stung by a jellyfish?
If you get stung by a jellyfish, that's a great example. Yeah, well,
What's the cure substance?
Oh, because you pee on it, it makes it better? Yeah. No, but that's a good example of the Th2 immunity, right? Is that you've got some foreign toxin that's come into your system, and it's immediate, right? This is an emergency. That's why we have that other response. Great segue, thank you. I should pay you for these. Emergency type. So your body has a different option. If we've gotten something like stung by a jellyfish and we need to respond to it really, really fast, it's helpful to have a system in our body that can surround that stuff and keep it from spreading to other parts, right? If you have an infection of some type, if you stepped on a nail, right, you want your body to clump around that infection site and start eating that and dissolve it, right? There isn't anything at that point to push out of your body. That's not how the system needs to work. Its job is to recognize those floating invaders that have penetrated on the inside of your body. Its job is to surround and dissolve, to be fast, and it will give you a 90% immunity. When we start talking about antibody titers, all the vaccination research is done on antibodies. the idea about herd immunity. Has anybody heard of herd immunity? The concept is that if you have people who have like a 90% antibody titer, it means a 90% reaction to whatever the microorganism is, then that is good enough to keep a whole population healthy. So you have to have a certain number of people, though, that have that high antibody titer in order for something called herd immunity, for people who have been vaccinated to protect the unvaccinated, quote unquote, which I've never really fully understood. I mean, if people haven't gotten the shot, shouldn't they be the ones worried about it, not the ones who have gotten the shot? I don't know. Doesn't that make sense? Yeah, it's kind of one of those anachronisms I really haven't fully understood yet. But yeah, it's cyclical, though. This is the trick with this type of immunity, that although you have 90% immunity for it, we haven't figured out yet. We know there's a range, right, between 3 months and 30 years for antibody life. Some of them have a really long shelf life, but some of them don't. And we haven't figured out, it varies from individual to individual. So to put yourself in somebody else's shoes for a moment, let's say you're in charge of the public health system of the United States, and your job was to make sure that people didn't get sick. It would make a lot of sense if you didn't know how long people retain their antibodies for, to go ahead and make a policy that says we're going to take the antibodies and create a vaccination schedule to boost people on the people who have the shortest lifespan for their antibodies, right? Because that way those short people are covered and then everybody else just gets bonus, right? That's how our vaccine system is set up. The reason that we have boosters is because we've studied who the short people are on that edge of the spectrum, and we give boosters based off those short individuals. Now, if you happen to have a longer lifespan to your antibodies than someone who has a shorter lifespan, wouldn't it make sense to wait longer in order to get your shots? Sure, right? Why do you need the shot if your antibodies level is still up at 90%? You don't. I'm telling you that right now. What you should do is get what's called an antibody titer. And Quest Labs, there's lots of labs here that will do the diseases of childhood panel for you. They'll go ahead and draw blood, they'll test it against the disease of childhood, and they'll tell you if you have antibodies or not. If you're a vaccine person and that's what you want to get a shot, give yourself an antibody titer first. Give your kid an antibody titer first before you go for your boosters. Why, give a kid extra vaccines if they don't need it? I think that's one of the areas where our public health system has fallen down a bit, is we haven't had the conversation really seriously about doing antibody titers. I've had some pediatricians tell me, well, that's because antibody titers start to vary, You can't tell from one day to the next what somebody's antibody titers are. And I say, if that's true, then all the research that is the backbone of vaccine policy, you're just telling me is invalid. Okay? If anybody's titers really vary that much, then you can't say that any of the research we've done to justify why we give kids shots is valid. Okay? If we're looking for 90%, then you got to just say, then that's 90%, and you're good there, right? So, yeah. So that's part of the question that we have. Yeah. Go ahead, Terry.
Medical too.
What's that?
We were forced to have shots.
Right.
So then when my time came up, they said, well, you need to do it again. And I'm like, well, I'm taking it. They said my antibodies were really, really high.
Yeah.
So I'm like,
there you go. Then I'm good, right?
I'm good.
Right. Yeah.
And that's it. They don't put, but a lot of hospitals are the nurses and stuff. They don't want it.
Yeah.
They'll fire them if they don't.
I know. I have so many nurses that have told me the same exact thing. If you're going to be in healthcare, you've got to get your Hep shot. Same thing with school teachers and things like that, right? And nobody asks, well, can I get a titer for it and see if I've already got antibodies? Why do I have to get the shot if I already have antibodies to it? That's a question we need to start asking, okay? Because it's available. I mean, if you have insurance, a lot of times your insurance covers
Would
it.
they accept that though?
Yes.
They have to. I mean, that is you are showing them your blood chemistry and saying, I have immunity to this. There is no reason to get a shot if you have immunity to something.
And not to change the subject, but I had something break on my head and I went in to go get stitches and they weren't going to do anything until I had a tetanus shot because I hadn't had one since whatever. And I pretty much had no choice but to take the tetanus shot because
Right.
they were going to not.
Yeah. Do you have tetanoid toxin, antibodies already? That's something that I mean, it's a quick lab test. This is not complicated biochemistry here. I mean, they've got serums in there, and it probably takes them like 15 minutes to run a whole titer on you. I mean, it's not that hard. Something really interesting happens between the two. I mean, we've kind of built up this Th1, chickenpox immunity versus the emergency type. But there's something really important to know about this, in that the two battle each other all the time for supremacy. That if you get sensitized with the chickenpox, kind of immune system towards something, then you won't develop the emergency response to it. Okay, that's okay, because if it's circulating in your body, you have a long-term response to this thing. If you get the emergency type response, you will not develop the long-term immunity type. What happens is when those two, when the thymus is making the differentiation, remember the little buddies it brings along with it? That was just a fraction of the little buddies. There are all kinds of chemical messengers. Do you remember back when I was telling you that babies give these chemical messengers into mom to determine what we're going to make, like a grocery list? Those things are called cytokines. And cytokines are chemical messengers our body uses all the time to make little signaling decisions. And those Th1 cells make different cytokines than the Th2 cells do. The presence or absence of those determines if you're going to be dominant one way or the other. Our preference is to have a long-term immunity response. That's what we really want to happen. It also changes your actual nerve system. Depending on the state of your immune system, if it's an emergency response, your nerve system creates an emergency alert. I mean, you've gotten a puncture, the emergency alert system in your body is your nerve system. It's a sympathetic nerve system, says, fight or flight, we've got a problem, okay? We need to fire ourselves up and really defend against this thing, all right? If your body has become sympathetic dominant, then you will have a Th2 shifted immune system. You'll have an allergy shifted immune system. You'll have an asthma and eczema kind of shifted immune system. You'll have an IBS kind of shifted immune system. If your immune system is rest and digest oriented, if it's oriented in the nerve system that helps slow it back down, then you're going to have a very different response. The parasympathetic immune system, I always remember, is being part of every relaxation thing that happens in your body. It's part of every elimination thing that happens in your body. When you inhale, sympathetically driven. When you exhale, parasympathetically driven. When you sweat and sweat comes out, parasympathetically driven. Fevers, sweat comes out, parasympathetically driven. Coughing, parasympathetically driven, right? Going to the bathroom, parasympathetically driven. Having a baby, parasympathetically driven. Whenever you digest your food, parasympathetically driven. It is the one that helps your gut digest its food. It's the one that helps shift your immune system into a long-term permanent immune system. It's the one that keeps your body nice and mellow, all right? So our goal then is to keep the body parasympathetically driven if we're going to start having a good functioning immune system, right? Stress hampers your immune response. We've heard that for years and years and years. This is why. This is why your doctors have been saying all along, well, stress impacts your heart. It impacts swelling in your body. It impacts your body's ability to get rid of fat. There's lots of things that happen with stress, but we haven't really put the pieces together yet. This is why. It shifts how your immune system starts to develop. I mean, that's how important it is. Gut flora variations. We have figured out, like I said before at the very beginning of the talk, depending on how you're born, when you come through that birth canal, you get mom's natural flora, right? You get that first meal. We've figured out that babies who have two very, easy to find bacteria, Lactobacillus and Bifidus, in their stool, that those babies have a Th1 shifted immune system. So babies who have other kinds of abnormal flora, let's say mom's gotten let's say mom had an ear infection when she was 12, and she never really established her own natural flora. So she's going to have different kinds of flora when she goes to give birth, because the stuff that is in the canal actually mirrors what's in the gut. Okay, so that's why even when we're pregnant, we've got to make sure. Like I always recommend, whenever it's time for the Group B strep test, we go ahead and look, and if we've got kind of funny-looking bacteria in there, we clean it out. Go ahead, and then we repopulate with the good probiotics to help that baby, when he or she comes out, get its first good kickstart. Okay, because it's that important. Adjuvants. Anybody here, a lot of the reason people have problems with vaccines isn't because they have problems with viruses. It's because of all the extra stuff that they put in shots. If anybody's ever read what's in one of the shots, it's a pretty long laundry list. I'll tell you that the reason that a lot of that stuff is there is really designed to create a Th2 response. It's designed to create the antibody response, designed to create a fight or flight situation inside your body. That's why you have redness and swelling. Remember complement, remember IgE. All of those things are there and ready to go because of what we put in the shot to make sure our body doesn't miss it. Remember when I was saying that when you breastfeed, that can actually impede the vaccine response? See what happens, right? Breastfeeding creates a Th1 immune system. It's creating the natural flora, it's creating that rest and relax, it's creating that good bond between mom and baby, right? When you start giving an injection in that time period when you're Th1 dominant, you aren't going to make a whole lot of antibodies to that because you're Th1 dominant. You've got these circulating antibodies looking around, sees the funny looking thing, and it kicks it out. I just had that happen 2 weeks ago. I had a little patient who's 1 year old. His parents decided to go ahead and give him the MMR shot. And he busted out with a fever, he busted out with the rash. I mean, he had a Th1 reaction to measles when he got the shot because he's been breastfed, he's been adjusted. I mean, his parents play with him and read with him. He's a smart little kid. But I did everything I could to keep that body Th1 dominant, parasympathetically dominant, and he had a Th1 reaction. First time I've ever seen it. That is exactly what you want to have happen. If you could come up with the best case scenario whatsoever with a shot, it's not taking it in your body and holding it in, right? Constipating it, right? It's getting it out. So when we breastfeed, sometimes we actually suppress what they're looking for. He'll go get an antibody titer, and I guarantee he's not going to have a very big antibody titer to that shot. And his pediatrician is going to call that a vaccine failure because he's not going to have a high titer. But guess what? He's got plenty of circulating Th1 cells that are going to see all three of those next time, and he's going to have immunity probably for 30 years for that, right? Probably for the rest of his life. So it's really interesting how that can happen, depending on how we prepare the nerve system. The disease of childhood, I mean, that's the big scary thing, right? That's the whole reason that we start talking about shots in the first place. There are 49 doses of 14 vaccines that children get right now on our schedule by the age of 6. Does that seem like a lot? Has anybody here seen outbreaks that have been like, oh yeah, that warrants 49 doses of 14 vaccines by the age of 6? I don't know. When I'm looking at some of the outbreaks that are going on, pertussis, whooping cough, measles, mumps, I look at the research when the CDC publishes it, and I wonder how many of those kids are, because they'll sometimes give you the numbers. That half those kids have already had shots. I know of a mumps outbreak in New York where over half the kids have been vaccinated twice against the mumps, and the boys still got it. So the recommendation again is to give a third shot, right? I mean, that's the way. If you're looking at how our public health system has determined the best way to keep the population safe, that is their only tool. It doesn't matter how much what comes out of the vaccine debate. They don't really care. Because as long as they have a tool and some sort of scientific backing to sit behind it, they're going to say, hey, listen, this is all we've got, right? There are, on that list, there are 4, of the 14 vaccines, there are 4 non-droplet type. So all of the diseases of childhood, measles, mumps, chickenpox, all the ones you get shots for, flu, only 4 of them come from other ways besides snot and coughing and that kind of stuff. Okay, they're all born this way. They come out this way. The other 3 come out through poop. That's polio, hep, and rotavirus. So if your kids are big into eating poop, you might want to get them shots. Okay. One's environmental. That's tetanus. Okay. Tetanoid actually, the bacteria that creates the tetanoid toxin actually is okay in the soil, and for a really long time. We had a really good relationship with that. In fact, it can be found in our natural flora and do okay in there. There is a what they call a non-pathogenic and a pathogenic form, and the one that's safe for us, the non-pathogenic form, does fine. When it gets out of control, that's when it starts wreaking havoc. You start having muscle spasms, you start having immune system irregularities like sensitivity to light and sound. You start getting some brain spasm things. There's some really weird things that happen with tetanoid toxins. But I really encourage you at this point to step back a second and say, okay, when we're looking at the big picture, if we've got the 10,000-foot view on things, especially people who are a little more environmentally aware, we start talking about an ecosystem. And we say that there is a place for everything in our ecosystem. That there is a reason why we have marshes, because it takes the salt out so it can filter in for the fresh water. And that environment helps certain types of bird species to be able to nest in there. and that there are frogs that can live better in that environment, and they're an indicator species for whether or not that's a safe environment going on. And then up and down the food chain, we have implications for the fish, for the different animals going on, right? We see the ecosystem as being one big biodome, one big whole, until it comes to viruses and bacteria. At that point in time, they become germs, and we have to eradicate them, right? I think we've done something really silly by creating this adversarial relationship with the microflora around us, and we're starting to understand that there are things that are good bacteria. If you think about, maybe that there is a grand design, that there is a grand scheme behind the disease of childhood, I want to tell you a quick story and let you marinate on it for a little bit. There was a pediatrician in New Zealand, and he used to do this little study where kids are about 5 years old and they get measles, okay? And he would ask them, okay, draw me a picture of a house. So he would draw your typical 5-year-old picture of a house. What's that look like? We got a box with a triangle roof. We got a rectangle door, right? We have windows, probably. Okay, so your typical 5-year-old picture of a house while the kid has measles. He would come back after they're through. It takes about 7 days. Remember, Th1 immunity. It takes a little bit of time, so then we get through the whole thing. And he would ask them to draw a picture of a house. Okay, have them do the same thing. There were concepts that didn't occur to them only 4 days earlier about drawing a house that start to show up. Maybe we start having a chimney with smoke coming out of it. There's a doorknob down there. We've got curtains in the windows, maybe little cross hatches, a fence around, maybe some flowers start popping up. I mean, these were developmental leaps that have happened because the body was able to go through this crisis. There's a doctor called Dr. Ianco, and he talks about fever. He's a medical doctor, and he says that a fever is kind of like a clearinghouse. That it's the opportunity for your body, especially when you're growing. I mean, we don't grow and grow and grow and are expected to keep all these cells. If we did, we'd all be 400 pounds by the time we reached adulthood, right? Because your cells are constantly turning themselves over. How do you get rid of them? You can burn them off. That's how the forest does it, right? You get all this dead wood and all these kind of things laying down in the forest. In order for new things to start growing up through the forest floor, you got to get rid of that undergrowth, right? So fires are the natural way that nature has of clearing that stuff out so new things can grow and develop, right? We have the same built-in mechanism. We've got fevers, we've got ways of pushing things out of our body, and there's a bonus to it. There are developmental milestones, I swear, that happen whenever kids get sick, whenever they go through an immune system challenge. And by being so afraid for the kids who are, look, there's going to be a small percentage in both of these camps, and this is why the vaccine debate gets so hot. There's going to be a small group of kids who die from childhood diseases. Usually their immune system compromised, and usually there's other factors going on, but they die, and that's horrible tragedy, right? There's going to be a small group of kids, although it's growing, who get injured, right? And so we have two camps who are looking at these two groups of kids and trying to defend vigorously both groups of kids, okay? And I think that's where we start breaking down, is that we stopped having a conversation about how do I identify the kids in both of those camps, and instead we're just talking about the shots and whether they're good or not, whether germs are good or not, right? We've got this dichotomy, and we haven't started to embrace this full picture of what nature does, right? We're talking naturalism versus artificialism. The natural way, birth to death, includes contact with all this other stuff. Do you realize that you have more microflora in your body than there are stars in the galaxy? You have different microorganisms. Your body, actually, when they did the Human Genome Project, figured out that a third of your genes code for these little viruses. You make your own viruses, by the way, and they help your metabolism go. They do all kinds of intercellular communication functions for you. I mean, only 9% of your DNA codes for what you see in the mirror. All right? We're making these things all the time. The concept that some germ came from Australia on some air current and suddenly got over here and now I'm sick with the flu makes no statistical sense to me whatsoever. Okay? I mean, stars in the Milky Way, one guy that I'm going to catch, right? Doesn't make any sense to me. So yet we've built this policy, and I'm okay because there's certain situations where parents need to do this. That we have this policy that says everybody should get the shots because that's what's best for you. Listen, if you can't be around for your kids to help get through those diseases of childhood, you absolutely should get in the shots. You ought to confer some level of protection to your children, okay? But if you've got, if you've made the values decision, because that's what it is, right? It's a values decision. In your family, to say, look, if my kid's going to get sick, I'm going to educate myself ahead of time about what the signs and symptoms of the disease of childhood are. I'm going to understand what I need to do to boost my child's immune system ahead of time. I'm going to be proactive with these things. And when things do happen, because kids do go through this process, like I said, it's just like fever, it's going to happen. When my child does go through this process, I'm going to know how to support that process and get the stuff out. Anybody here ever potty train their kids? Okay. Did you say that it was okay to go ahead and poop in the middle of the store? No, right? No. No? Okay, good, thanks, right? No. There are times and places to go ahead and release that stuff. If your kid's sick, you keep them home, okay? You don't ship them off to daycare and let them shed stuff all over the place. Like I said, if people are afraid of one thing, it's the unvaccinated kid getting all the vaccinated kids sick. So one, to ease their minds, keep the kid home. B, rest and relax, right? That's the immune system and nerve system we're trying to encourage anyway. We need to do that instead of being in that environment in the first place. It's an opportunity for the whole family to just take some slow time and get through the healing process. But it's a bigger responsibility. If you don't have the time, because not everybody has the time, we have parents, and both parents work, we've got a lot of work that has to do, especially in this economy, then give your kids some sort of protection. Let them fend for themselves when they're 18. Okay? Say, hey, you can make the decision at that point in time, but they're going to need boosters because they're not going to have as long-term immunity to it. Okay? But when they're 18, they can start making decisions. Now, like I said, once they're shifted Th2, they're going to be more prone to things. They're going to have a lot of inflammation in their system. They're going to have more complement. They're going to have a lot more IgE, looking for really weird-looking things. Okay? So when they get the shots, you want to make sure that they're eating really, really well. That they're not eating really weird-looking things like gluten and dairy and peanuts and eggs and soy, right? These are funny-looking things that the body is getting really sensitized to, and I swear, people in the military end up with some of the strangest GI symptoms and the weirdest autoimmune diseases and the strange things because they get to be our guinea pigs, right? They get to be vaccine guinea pigs, and we didn't sign up for that, but that's what happens anyway. And suddenly, if you eat the military diet, it's a very meat and potatoes diet, right? I mean, right? I mean, you're getting your scientifically regimented number of carbohydrates and all this, but it's not great quality food. I mean, it's full of the things that cause inflammation inside your body, and you're getting these shots. No wonder we end up with these kinds of problems. We've talked about that the best way for that child to get reshifted. I mean, if we didn't do the canal, then we go ahead and we're doing the breastfeeding. If we can't do the breastfeeding, you've got to supplement with the probiotics. Lactobacillus and bifidus are the two that I don't care what the label is. You want to do something that's fairly low sugar. Okay, they need a little something to eat, but they don't need to be loaded with sugar. But you need those probiotics. If you're nursing, you can go and put them right on you. Okay, break up the capsule, put it right on you. Let your baby nurse that way. Eat real food, anti-inflammatory foods. I don't think I need to talk much about this in a health food store, right? I mean, we're talking about what causes inflammation. We're talking about foods that do anti-inflammation. I mean, choose to go that pathway if your body's got a Th2 response to something, okay? The more that you're able to shift your body to a Th1 response, the natural kind of chickenpox type, the better off you're going to be. Resting is so important. Like I said, the parasympathetic nerve system is the immune system, or the nerve system of rest and digest. Every time, like when your heart beats, boom, that's the sympathetic. You actually do this part, boom, for twice as long. So if you cut a heartbeat into thirds, 2/3 of that is parasympathetically resting, right? We don't think of our heart as something that rests 2/3 of the time. It takes 66% of its time is just kind of lounging, right? It's working all the time, right? No, it's not. It's not. That parasympathetic system, if it wasn't there, we would always be G, which is part of the reason that we end up with heart disease when we're constantly stressed, right? So make sure you get plenty of rest. Exercise is so important. We've said for years and years that exercise helps boost your immune system, right? This is why. Because it helps get the body into that cell-mediated immunity, that it's always circulating, it's looking for new things. We've got things like tumor necrosis factor alpha. I mentioned all those little cytokines that Th1 immunity cells bring with it. Just like it says, tumor necrosis, meaning dying, factor alpha, is one of the chemicals that we've identified that actually, we're always making cancer cells inside our body. We're always making tumors. I don't know if you know that or not, but we've got that chemical that's always looking for those weird-looking cells and saying, you're not self. Come on, Guido, let's go get you. We're always doing that, all right? And if we're not able to constantly be in a Th1 shifted state, then I really do think that some of these long-term health disease processes that we have going on, like cancer, like diabetes, are partially because we don't have enough people who are shifted Th1. The next thing is learning. When you start learning things, your brain starts to do something really interesting. The cortex, the outside of your brain, as it starts to get stimulated, starts stimulating the parasympathetic nerve system. How do you do that with your kids? You read to them. You have them read back to you. How do you do that as an adult? Because once we get outside of the halls of academia, unless we're constantly, challenging ourselves to learn and grow, we kind of miss out on it. But I heard once that the average American's commute is about 30 minutes back and forth to work. If you listen to an audiobook as you're going back and forth to work, they say that you can get the equivalent of a full semester's tuition worth of classes in a year. That you'll listen to about 12 credit hours worth of new information if all you do is you pop in an audiobook CD every time you drive back and forth to work. That's pretty easy, right? And you're boosting your immune system. Right? So learn something every day. Or you can learn Spanish. Yeah, right? That's what I'm doing. Nerve system balance. This is where I come in as a chiropractor. If I ever have somebody who's having an immune system challenge, it's the first thing I look for. If I have somebody who's stressed out, it's the first thing I look for. If I have someone who's going into labor, it's the first thing I look for. I look for balance between the parasympathetic system and the sympathetic nerve system. And I found a very big difference in being specific with those adjustments. Just going ahead and racking and cracking and doing the flying 7 and getting all those bones to move doesn't seem to have the same impact. And that's really where my training comes in, as someone who understands how the nerve system functions, is that we need to do things to boost the parasympathetic nerve system in order to keep the immune system healthy. If there's nothing else that you can do, get an atlas adjustment, that very top vertebra or the one down here in your sacrum, that's where those nerves come out. Boosting those right there with really easy adjustments, light force techniques, works brilliantly for a lot of this stuff. The kid that I mentioned earlier, going through that, I adjusted him 5 times in the span of 5 days, okay, before his body finally broke through all of that. I mean, he was going fever back down, fever back down. And then he went fever, broke out in rash. I went, yay! Because Th1 response. It meant we kept his immune system Th1 dominant, right? Relationship building. In the 6 tenets I have in my practice, they're up here. But being respectful, building relationships is so important. When you get into that connection, that love connection that you have with your significant other, with your children, that feeling feels good, right? It lifts you up. That's a parasympathetic kind of response. Have a pet, If you don't have a significant other, get a little puppy. We have a parrot who doesn't love Erica as much as it loves me, and so not at all. So part of my job at some point in time, I know, is to get her a puppy so she has something to snuggle with. That's going to help boost her immune system, right? I mean, that is part of what.
That's a good way to put it.
That's right. Yeah.
Babe, I need my immune system.
Yeah, right. You got to use that argument more often, right? But also learning how to communicate in someone else's love language. We talked in the last talk about the 5 love languages, right? That everybody has a different way of communicating that stuff. Understand, how your personality type works, how it interacts with somebody else's, and try to communicate with them on that level. Doesn't necessarily have to be romantic relationships, doesn't have to be familial, and it can be in your work environment. There's a lot of places, but if you can make good heart connections with people, believe it or not, it's actually been shown to boost your health, and that's why. It's because it boosts that level of your immune system. Okay? So, there we go. If we're talking about naturalism versus artificialism, you see there's a lot of low-cost things that you can do, right? I mean, it doesn't cost you much to get educated. You go to your library. Probiotics are not that expensive, right? Reading to your kids, learning something, building that kind of love relationship, going for a walk. I mean, we're talking about low-cost interventions here, right? Now, the amazing thing is when you start regularly applying those kinds of things, you can see things like asthma, allergies, eczema. People always ask me, what should I do about this? What should I do about this? I say, well, first clean the garbage out of your system. Once we clean the garbage out of your system, then we got to shift your immune system. And the way that I can help you with that is by shifting your nerve system. And if we're able to do that on a regular basis, I've seen the most amazing things. Used to have hay fever as a kid. I used to be the little kid that was hopped up on Benadryl, sitting there on my recliner every detasseling season out in Nebraska because I would get so stuffy and I would just sneeze and sneeze and sneeze. You can ask my grandparents that they would give me a down like a feather pillow, and the next morning I would just be a mess, just sneezing and sneezing and sneezing. I was the sickest little kid. Every time I came back from my grandparents' house, out in the farm with new people, asked my dad, I was sick every single time. He used to get so mad. He's like, why do you always get sick whenever you come back home? And it was because I had a really crummy immune system. Guess what my favorite food was? I loved milkshakes. Oh, I loved them. I used to have a challenge when I was like 11. I had one summer where I was on this quest to drink the biggest vanilla milkshake I could possibly find. The one that beat me was at the Yum Yum shop in Buffalo, New York. And it was like as big as my head. It was amazing. But I had issues with dairy. I was out of alignment. I had balance problems. There were things that were going on in my nerve system that were soft neurological signs that nobody figured out how to pick up. Until I started getting adjusted regularly, until I started shifting my diet, I used to have seasonal allergies all the time. As I started to shift my immune system, I guarantee if you do an antibody titer with me, I probably have some autoimmunity to things like, whatever kids are bringing into the office. But I would say that I'm probably more balanced TH1 because I don't have the same reactions to the natural, to the pollen causing my allergies that I used to have. Okay? So these are it can take some time, but these are interventions that you can do because your body's always going through the rebuilding process. Yeah. Does that give you some tools, like when you're talking to, whether it's a pediatrician or talking to your parents about choices that you're going to have, or your spouse or your kids about what they need to do in order to keep their immune systems healthy? Does that give you some tools that you can use? Yeah. Okay. Good. Super. Our next talk next month is going to be on. Holy comments! Do you have the calendar there?
October 12th?
October 12th. It's holism versus reductionism. And that one's going to talk about treating the body as a system, as an interrelated, connected system, versus treating it as a bunch of parts. We're going to get into some really interesting things about genes when we do that talk. Like I said, 9% of your genes are, make up what you are on the outside. When we started the Human Genome Project, we thought that the whole idea behind unlocking the DNA code would be that we would find the solution for all of man's ills. We thought we would figure it all out. What we've learned instead is that there are so many factors on the outside that influence your DNA that the central dogma of biology, the DNA, the nucleus is the brain of the cell, has been completely disproven. It's a whole new field of epigenetics come out, and we're going to talk about that in the next talk. Thank you very much for coming in. Also, if you haven't joined the Pathways Connect group, that's the other thing that I like to promote. Pathways Connect Southwest Florida. You can find us on Facebook. We get together once a month and talk about articles in a magazine called Pathways to Family Wellness. Right now we're meeting over at ADA's the last Friday of the month, but we'll see where we are at the beginning of next year. So.
And you're going to take a picture.
Okay.
I just want to take a picture.
Oh, a group photo. Yeah, thank you.
They'll just be the back of our heads. And
Yeah.
so post it for the event. And did you post the picture of the kid pooping in the restaurant? Did you see that?
No, I did not.
Somebody did it on Facebook. A mother had her child, it looked like it was a food court, or at least a big restaurant, and they had one of those potty seats. They put it on a chair. She was drinking her soda and sitting on the potty in the middle of the restaurant. So when I saw that, don't poop in, I'm like, yeah, are you the one that posted that? I saw that today. I'm like, are you kidding?
I'm going to grab that for presentation. I'm totally grabbing that. I use America's Funniest Home Videos all the time for Why Kids Need Chiropractic. I am not above using some kid pooping in the middle of a food court in a presentation to get a point home. Yeah. Yeah. So yeah, Pathways Connect, we meet last Friday of the month. You can check us out on Facebook, Pathways Connect Southwest Florida. We'd love to have you. Thank you. Thanks for hosting very much to Skinny Pantry. Woohoo! You rock.
Thank you.
Thank you very much.
You're very welcome. Thank
We'll
you for
see you
coming
Tuesday.
tonight. Yeah, all righty.
Good to see you. Are you still working?
Yep. Still working about 6-hour shifts.